So, good evening, everyone. So, today we will be doing the second chapter, that is the atomic model. Okay, so let's start with the first question. First question regarding the atomic model was write the postulates of Bohr's model. Hydrogen atom. And along with it, this was the first question. So what are the postulates? Niels Bohr was the first person who quantitatively gave the general features of the hydrogen atom structure and its spectra. So his theory was used to evaluate the several points in the atomic structure and spectra. So the postulates of Bohr's atomic model for hydrogen were the electron in the hydrogen atom can revolve around the nucleus in a circular path of fixed radius and energy. And what are these paths called? These are the orbits or the stationary states. These circular orbits are concentric, concentric. Concentric means like this. Orbits, second orbit. These two orbits have the same center. So this is referred to as the concentric. Okay, so this is the concentric part around the nucleus, and the energy of an electron in the orbit does not change with time. Then electron moves from the lower stationary state to the higher stationary state. And when an electron moves from the higher secondary state to the lower secondary state, emission of the energy takes place. And when this electronic transition takes place between the two stationary states that differ in energy by delta E, then it is given as delta E is E2 minus E1, which is h nu, right? And the frequency of the radiation absorbed or emitted is nu, which is E2 minus of E1 by h. And E2 and E1 are the energies of lower and the higher energy states, right? And the angularity, the angular momentum of an electron is given by the formula mvr is equal to nh by 2 pi. An electron revolve only in the orbits for which its angular momentum is the integral multiple of h by 2 pi, right? So these were the postulates regarding the atomic model. Okay. Okay, let me see the next question that has come in your exam. Again, the same question has come. What are the postulates of the Bohr's model of hydrogen atom, and discuss the importance of this model to explain the various series of the line spectra in the hydrogen atom. So this was something that came in the year of 2023. Let's move to the other year's question. So, okay. The question came to be as, right, okay, I'm writing the question. Okay, so what is the question? The question came to be as the salient features of quantum mechanical model of atom. Okay, so what are the salient features? First feature is energy of the electron. First important feature is energy of electron. So what does this state? That the energy of the electrons in an atom is quantized. It can only have certain specific values. Second is the existence of the quantized electronic energy level is a direct result of what? Wave-like properties at the electrons and an allowed solution at the Schrodinger wave equation. Third is all the information about the electron. That psi thing. That psi thing. That all the information about the electron in an atom is contained in its orbital wave function. What is this psi? This is this orbital wave function. Okay. This is this orbital wave function. And quantum mechanics makes it possible to extract this information from psi. And the path of the electron can never be determined. Just wait for once. Okay. So this is the orbital wave function. Next comes the path of the electron can be never determined uh, accurately. So this is the path of electron. So the path of the electron can never be determined accurately. Therefore, we only find the probability of the electron at different points in space around an atom. And the probability of finding an electron at a point within an atom is directly proportional to psi square, mod of psi square. At that point, psi square is known as probability density, right? So this psi square is probability density. And this value is always positive. Always positive. Okay. And from the value of psi square at different points within the atom, like we can be able to predict the region around the nucleus where the electron can be found mostly. This is the kind of the thing questions have been asked. Okay. What is the next question? Okay, then next is a very common question that have been asked to you a lot of time. So this question is, how are the quantum numbers? NLM arrived at. Okay, so and what is the significance of these quantum numbers? Okay. So in general, a large number of orbits are possible in an atom. These orbitals are distinguished by their size, shape, and orientation. An orbital of the smaller size means there is more chance to find electrons near the nucleus. And the atomic orbitals are precisely distinguished by the quantum numbers. Each orbital is designated by three principal quantum numbers. One is the principal quantum number, which is n. Second is the azimuthal quantum number, which is the L. And third is the magnetic quantum number, which is M. Okay, N, L, M, N. So principal quantum number was introduced by Niels Bohr and it reveals the size of the atom. So what do they do? Reveals size of atom. Second is the azimuthal quantum number. What does this do? It was proposed by Sommerfeld and is known as the angular momentum quantum number or subsidiary quantum number. Indicates the shape of this indicates mostly the shape of the orbitals. Okay, and third is the magnetic quantum number. It was proposed by Lande. So this shows the orientation of the orbital in space. Shows orientation of orbitals. Where? In space. Right. So this shows the orientation of the orbitals in space. Now, regarding, there is an important chart that we always do. What is the name? Like the energy levels and the subshells. So that is, first is the principal quantum number, right? N. Second chart represents azimuthal quantum number, which is L. Then comes our symbol. Then comes the number of what? Subshells. Right? Then comes the number of subshells. So first n, if n is 1, L will be 0. Right? And what is this symbol? S. And how many subshells will be there? 1. That is 1s. If this is 2, so L will be 0 and 1. What will be the symbol? S and P. And what is this? This will be 2. That is 2S and 2P. Third is the 3. If N is 3, then it will be 0, 1 and 2. So that will represent as S, P and D. So of course this will be 3. 3S, 3P, 3D. Fourth is like this, 0, 1, 2, 3. So there it will be S, P, D, F. And of course this will be 4. 4S, 4P, 4D, 4F. Right? These are the thing. Wow. Another important chart is this one. Subshell, then L value, and M value. This will be minus L to 0 to plus L. And these are number of orbitals. That is 2L plus 1, right? And these are S, P, D, and F. L values will be 0, 1, 2, 3. What will be this? 0. This will be -1, 0, +1. What will be this? -2, -1, 0, +1, and +2. And this will be -3, -2, -1, 0, +1, +2, and +3. This is 1, then 3, then 5, then 7. Like 1, 2, 3, 1, 2, 3, 4, 5, and here it's 7. Okay, so these are the representations. Now, if I am asked to do the schematic presentation, that is the psi value and everything, so how will that look? Right? And here will be the like this. And then just put the respective values. So if this is 0, then this will be 1. Okay. Not like exactly 1. We can do the calibration here. Then here there will be another point. Not that. This will be our midpoint. Then comes and finally so what will be the values? Just tell me. This will be M is equal to +2. And this will be M is equal to +1. This will be 0. And here this will be M of -1. And finally here, this will be M of -3. And this is M is plus of 3. Here this value will be M of minus of 3. This is -2, sorry. So this is the overall diagrammatic representation of whatever you are writing. Okay, coming to the next question. Again, the next question has been same, that what are the quantum numbers and explain the significance of the quantum numbers. This is just something we have done, right? Okay. Okay, then coming to the next year's question. These hybridization questions we have done a lot of times in the class. I'm not just repeating it again and again because these are the things we have done. Okay. Okay. The next thing that has come in your exam. So that is, oh, okay. Next year, no question has come from the atoms chapter. So fine, those questions we will not be solving. Okay, wait. Then the okay. Just try to solve this question. This is not from the atoms question chapter, but this is an important question that has come in your exam a lot of times. The question is something regarding the balancing. Okay, something regarding the balancing. MnO4 minus, which is in the aqueous phase, plus of iodine, which is again in the aqueous phase, that results in the production of MnO2, which is solid, of course, and iodine, which is a solid again. Oh, wait, why is this jumping? Okay, so if this is the thing, balance this equation in basic medium. balance in basic medium, not acidic, basic medium, by ion electron method. Electron method, right? So this is the balancing thing. Now, what is the first thing? First is the write the reduction half cell. What was the equation again? MnO4 minus, which is aqueous, plus of iodine minus, which is also aqueous, results in the production of MnO2, which is solid, and iodine, solid. First, write the reduction half cell and the oxidation half cell. Reduction half cell. And here, this is the oxidation half cell. Right. So reduction half cell, that will be MnO4 minus to MnO2, this thing. So MnO4 minus to MnO2. So to balance, first you need to balance the oxygen. Manganese is already being balanced. So that is the reason you need to balance the oxygen. So that is MnO4 minus and MnO2. So there is a reduction of like 2 oxygens are less here. So that means we have to add 2 water, 2 H2O. So what is here? Oxygen here. See, the oxygen is being balanced. O4 and O4. Here 2 oxygen, here 2 oxygen. Oxygens are balanced. So what is the overall equation now? MnO4 minus plus 4 of H2O, that results in the production of MnO2 and 2H2O and 4OH. If I break, I can write it like this, right? So this is the balancing of hydrogen. Hydrogen here gets imbalanced. So if hydrogen is imbalanced, we need to add the water in the left-hand side. So that's what we have done. This is the balancing of oxygen. This is the balancing of hydrogen. Now let's do the oxidation half cell. So that is I2 iodine and 2I. Production of I2. That is simple, just simple. Here the iodine is being balanced. So 2I2 plus 2 electron. This is charge balanced. So here it is oxygen balanced. Here it is hydrogen balanced. Here it is iodine balanced. And here charge balancing is being done. So now what we need to do, just put these equations and add them. That is MnO4 minus plus 2H2O. That is MnO2 plus 4OH minus. Simple. MnO4 minus plus 2 of H2O plus of 3 electrons producing MnO2 plus 4OH minus. So this is what again charge balancing. Right, charge is being balanced. Now just the whole thing. 2 of MnO4 minus plus 2 of H2O plus of 3 electrons. This will give MnO2 plus of 4OH minus. And 3 of 2 iodine I2 plus 2 electrons. And so what we get from this? 2 MnO4 minus plus 4 of water plus 6 electrons producing 2 MnO2 and 8 OH minus. And here 6 iodine producing 3 iodine plus 6 electrons. So whatever you get after adding, that is your final answer. 2 MnO4 minus plus 4 water plus 6 iodine, 2 MnO2 plus 3 iodine plus of 8 OH minus. So the above equation is the, like this equation is the balanced. Okay, so this is our final balanced equation. This question has come in your exam a lot of times. And this is an important question also. Okay, so again the question has been asked as what are the postulates of the Bohr's atomic model and state the Hund's rule and the Afbau principle. So I hope you know this answers. These are just the definitions part. Okay. So what is the Hund's rule? Hund's rule deals with the filling of electrons in degenerate orbitals, and it states that the pairing of the electrons in the orbitals belonging to the same subshell like P, D or F, that does not take place until each orbital belonging to that same subshell has got 1 electron each. That is, all the orbitals are singly occupied. And the Aufbau principle states that in the ground state of the atoms, orbitals are being filled in order of their increasing energies, right? So these are the thing that they have asked you. Okay, next question at the same postulates of the Bohr's model, and again explain the significance of the quantum numbers. So I'm not making you do it again. We have just done in today's class. See, whatever I have taught, those questions are coming repeatedly. So just follow and give your exam properly. Okay. Is there any more questions left? No. All are the same. What are the Bohr's postulates? Bohr's postulates maximum question has come, and formation of the lines in the hydrogen spectra. These questions have come in your exam maximum times. So just go through them, and the balancing I think sir has done with you all. So these are the things that you need to do. Okay. Okay. So thank you.